In this video, we're going to analyze parabolas with vertex at a point h, k. Now, if a parabola with vertex at the origin and axis of symmetry along a coordinate axis is shifted h units horizontally and k units vertically, the result is a parabola with vertex at the point h, k, and axis of symmetry that would be parallel to a coordinate axis. The best way to learn how to analyze a shifted parabola is to think of shifting the parabola from a vertex at the origin and remember that A is the distance from the vertex to the focus. To emphasize the connections, on the next 4 slides we present the corresponding information of a parabola with vertex at the origin and its shifted counterpart. Now on the left-hand side of this slide, we have the graph of the parabola y squared equals 4a times x, which is a parabola opening to the right, the vertex at the origin, focus at the point a, 0, and directrix is the line x equals -a. Now on the right-hand side of this slide, we have the graph of the shifted version, which has equation, the quantity y minus k squared equals 4a times the quantity x minus h. This is a parabola opening to the right, with a vertex at h, k, focus at the point h plus a, k, and the directrix is the line x equals h minus a. Now let's note that the focus and directrix both lie a distance of a from the vertex. On this next slide, on the left-hand side, we have the graph of the parabola y squared equals -4ax, which is a parabola opening to the left, vertex at the origin, focus at the point -a, 0, and directrix is the line x equals a. On the right-hand side of the slide, we have the graph of the parabola with equation, the quantity y minus k squared equals -4a times the quantity x minus h. And this is a parabola opening to the left with vertex at the point h, k, focus at the point h minus a, k, and directrix is the line x equals h plus a. Again, notice that the focus and directrix are distance a from the vertex. On this third slide, on the left-hand side, we have the graph of the parabola x squared equals 4ay, which is a parabola opening up, the vertex at the origin, focus at the point 0, a, and directrix is the line y equals -a. On the right-hand side of the slide, we have the graph of the parabola x minus h quantity squared equals 4a times the quantity y minus k, which is a parabola opening up with vertex at the point h, k, focus at the point h, k plus a, and directrix is the line y equals k minus a. Again, notice the focus and directrix both lie a distance a from the vertex. On the fourth slide, we'll make a comparison. On the left-hand side, we have the equation x squared equals -4ay. Vertex is at the origin. Focus is the point 0, -a. Directrix is the line y equals a. On the right-hand side, we have the parabola with equation, the quantity x minus h squared equals -4a times the quantity y minus k. Its vertex is the point h, k. Its focus is the point h, k minus a, and the directrix is the line y equals k plus a. Again, notice the distance relationship that the focus and directrix are from the vertex. Now that we have made the connections between the shifted versions of the parabola as compared to the versions whose vertex is at the origin, let's go ahead and solve a couple examples. In this example, we're told to find an equation of the parabola with vertex at the point 2, -1, and focus at the point 4, -1. We're then told to graph the equation. Personally, I like to begin by plotting the information we are given. Now, using a rectangular plane with x-axis from -2 to 9 and y-axis from -6 to 6, let's plot the vertex at the point 2, -1. Then let's plot the focus that's given in the problem statement at the point 4, -1. Let's notice that the vertex and focus both lie on the horizontal line y equals -1, and this is the axis of symmetry. Now the distance a from the vertex to the focus will be a equals 4 minus 2, which is 2. Since the vertex is midway between the focus and directrix, then we know that the vertical line that lies a equals 2 units to the left of the vertex will be the directrix. Therefore, x equals 0 is the equation of the directrix. Now let's find the equation of the parabola. And since the focus lies to the right of the vertex, then we know the parabola opens to the right. And therefore, the equation must have the form the quantity y minus k squared equals 4a times the quantity x minus h. And we know that the vertex h comma k is the point 2 comma negative 1. And we had calculated a to equal 2. So substituting this information into our general equation, we can write y minus negative 1 all squared equals 4 times 2 times the quantity x minus 2. Simplifying, we get the equation y plus 1 all squared equals 8 times the quantity x minus 2. And this is the equation of our parabola with the given information in the problem statement. So now we want to graph the equation. So to finish sketching the parabola, let's find the endpoints of the lattice rectum. And to do this, we'll substitute the x value of the focus, which is x equals 4, into the equation we just wrote for the parabola. Now, substituting x equals 4 into the equation, we get the quantity of y plus 1 squared equals 8 times 2. Now, using the square root principle, right, in essence, square rooting both sides of the equation, we can solve for y and write y plus 1 equals plus or minus 4, and therefore y will equal 3 and y will equal negative 5. So after plugging x equals 4 into our equation, we have the two corresponding y values, and we can plot the points 4, 3, and the point 4, negative 5 as the endpoints of the lattice rectum. So now we can sketch the parabola passing from the vertex through the point 4, 3, and then from the vertex through the point 4, negative 5. In this example, we're told to analyze the equation of the parabola x squared plus 4x minus 12y plus 16 equals 0. Now, to analyze this equation, we first need to complete the square involving the x variable. And to do that, we want to isolate the x variable on the left side of the equation and write the equation as x squared plus 4x equals 12y minus 16. So now to complete the square on the x variable, you note that the coefficient of x squared is positive 1. So what we will do at this point is take half of the coefficient of x and square it and add it to both sides of the equation. Therefore, we'll take half of 4, which is 2, then square that value and get 4, and we will add 4 to both sides of the equation, and we write x squared plus 4x plus 4 equals 12y minus 12. Now the left-hand side of the equation is a perfect square trinomial, and we can factor it as the quantity x plus 2 squared. And on the right-hand side, we'll factor out the common 12 and write as 12 times the quantity y minus 1. So we've transformed the equation into the general form that is the quantity x minus h squared equals 4a times the quantity y minus k. So for our equation in the proper form, we can identify that h equals negative 2, k is equal to 1, and a will equal 3. So let's plot the information that we have in our xy plane. So here we have an xy plane from negative 9 to 5 on the x-axis and negative 2 to 6 on the y-axis. So the vertex being the point h, k, we can plot the vertex at the point negative 2, 1. Based on the form of the equation, we know the parabola opens up, and since a equals 3, then the focus lies 3 units above the vertex at the point negative 2, 4. Also, we know the directrix lies 3 units below the vertex, thus the horizontal line y equals negative 2 is the directrix. Now to sketch the parabola, let's find the endpoints of the lattice rectum. So to do this, we'll substitute the y value of the focus, which is y equals 4, into the equation of the parabola. Now, substituting y equals 4 into the equation, we get the quantity x plus 2 squared equals 36. Again, using the square root principle here, we're going to write x plus 2 equals plus or minus 6, which gives us x equals 4 and x equals negative 8. So now we have 2 points we can plot in the xy plane for the value of y equals 4. Now those are the points negative 8, 4, and the point 4, 4. Now that we've plotted all of the guiding information, let's go ahead and draw the parabola. So we'll draw the parabola extending from the vertex at negative 2, 1 through the point negative 8, 4, and from the vertex through the point 4, 4.